Hello team and welcome back to the channel. So when you are going for DevOps interviews, one of the most common question that is definitely going to be asked is explain day-to-day activities or tasks from DevOps point of view. So as a DevOps engineer, you have to explain those things, and this is where most people get stuck because you might not be aware about what kind of real-time task that we used to do as a DevOps engineer in our company. So for this purpose, what we have done, me and one of my ex-colleague, we have decided to make a list of around 20 tasks that we used to do in our project in our company. Now, in order to make sure that you have a very good understanding of all those tasks, what we have done, we have added with each task proper explanation, plus with each task there will be scenario based examples for you so that you get a very good understanding of everything that I am going to explain now. Okay, and yeah, make sure to take a note of everything that I explain here, because when you are going for interviews, this is going to be really useful. One more thing, these are the actual tasks that we used to do in our company. Okay, so yeah, with that being said, let's get started. So then before we get started, just one more thing. If you're new on the channel, make sure to subscribe. It keeps us motivated to continuously upload amazing hands-on videos on our channel. As of now, we are running a small series that is going to be 10 real world projects. We have started from here. As of now, 4 projects we have uploaded. You can check this out. Also team, for those who are preparing for DevOps interviews, you can check out our batch 9, which is going to be starting from 25th of March. This course is going to be live plus recorded, where we have live sessions on weekends. Wednesdays we have doubt session. It has total 20 mega projects. These projects are not going to be hello world kind of projects, but very complex and multi-tier projects, where we have different kind of database integrations, we have microservice based projects, we have network based projects, and all sorts of projects we are having. Plus, this course is going to be comprehensive, 150 plus hours of content, where we have more than 14 modules. Okay, and best part about this course is that if you are going to transition to DevOps, we will be guiding you how to present yourself and how to showcase your DevOps knowledge in your resume as well as in interviews. So that I'll be also explaining you the projects that I have worked on, what was my role as a DevOps engineer, what kind of task I used to do. All those things will be done one to one. Okay, so yeah, if interested, make sure to check it out. As of now, we are having a discount of 1500. That means you'll be able to get this course for just 8500 rupees. So make sure to check it out, and if interested, you can enroll. And now we can get started with the day-to-day activities of a DevOps engineer. So first task that we have is monitoring and alert handling. Now when we talk about this, what exactly we have to do? So see, I'm going to explain this with a scenario based example. So let us say that around 2 a.m. in the morning, you receive a notification. You are receiving a notification from a platform that is known as PagerDuty Alert. Now, what is PagerDuty Alert? So basically, it's a platform for alerting or basically sending notification. And this platform can be integrated with tools like Prometheus, Grafana, like that. So basically what happens, let's say during at night, suddenly some some application pod is using so much of CPU. Okay. So inside Grafana, PagerDuty Alert, it was able to see that around 90% or above is of the CPU or resources are getting utilized. So immediately PagerDuty Alert platform started or sent a notification to the first on-call person. Now, what is first on-call person? So basically, these are going to be people who are either working overtime, or people who are working in a different shift, or basically people who are available at the time. So first notification is going to be sent on this person. Side by side, an incident will be created. Okay. So once this person receive notification, he has to start looking on the issue. But for some reason, let us say that this person is not available. Then what is going to happen? This notification from PagerDuty is going to send to next available person. Okay. Second person, whoever is available. Next thing what we have to do, so as soon as we receive the notification, what we have to do, first of all, we have to go inside Kubernetes. Okay, inside Kubernetes, what we have to do, first of all, from the Grafana, we got to know that, let us say that a specific pod known as payment is having issues. Okay, it is utilizing a lot of resources, and more than 90% of the resources utilized, or 90% of the CPUs utilized. So we went into Kubernetes, we opened the payment pod. First thing that we have to do is run the command to check logs. The command that we have to run is going to be kubectl logs, then pod name. And if it is in a specific namespace, then we can write, let's say it is in prod. So we can write -prod. In logs, what we have to do, we have to search for specific keywords. What kind of keywords? For example, OM killed. OM killed specifically occurs when out of memory, like issue happens. Okay, so these are the keywords that we have to look first of all in logs, and in logs only we will be able to get some information about what exactly is happening, why this spike is coming. Okay, now second thing that we have to do is describe the pod. From here we will be able to get information if pod is running right now successfully or not, also when it was last restarted. Okay, those kind of information will be able to get from these two commands. Okay, now so basically in order to fix this we have to monitor it first properly. For some time we have to check like from how long this 90% usage is happening. So first thing that we can try in order to fix it is run a command to scale, to increase the number of replicas. So we can run a command like this: kubectl scale deployment payment service, the pod name basically, and number of replicas we can increase to 5. Okay, and now we have to monitor it. So if this issue if this command is going to fix the issue, and after monitoring for quite some time we saw that okay, this has been the issue has been fixed with this, then next actions would be to set up an horizontal pod auto scaler. We have to set up that, and then we have to apply it. kubectl apply -f, then whatever the HPA YAML file we have created. Okay, so this will be the kind of permanent solution. Okay, again one more thing you need to understand, as I have explained here about specific scenario like this one. Okay, OM killed or something, but again there could be different issues also. This is one just scenario that I have explained you. So monitoring and alerting alert handling can be done using this in this format, and these are the actions that we do with respect to monitoring and alert handling. If any issue is occurring, in this way we can monitor it and we can fix it. Okay, so this is the first task. Now, and again it's not like that it's going to happen every single day, but this is some kind of task that we did on regular basis. Now let us move to second task. So team 9, let's talk about second task, where we have the task CI/CD maintenance and creation of pipelines. Now obviously if you are going for interviews, you cannot say that okay, as soon as joined every day I was creating pipelines. Obviously you are not going to do that. Why? Because in companies you are not creating pipelines or new pipelines every day. Instead what we do is maintaining the pipelines, make sure that whatever issue is coming we have to fix it. We are making sure that like pipelines runs properly. Okay, so let me explain you with an example. Now when you have to say this creation of pipelines, so this you have to say, you can say in this format that whenever new client onboards, then you can connect to client for a few days and you can guide them how to set up the pipelines. Okay, or if you are dedicatedly supporting some client, then you have to create the whole pipeline from scratch. Okay, but again this is going to happen in this scenario. Second scenario where you will be creating complete new pipeline is that if you have some kind of new project. Okay, or if you have specific task that needs to be done, for that also sometimes we create new pipelines. Okay, so new pipelines will be created in certain scenarios, which will be this. Now talking about CI/CD maintenance, what exactly will be happening and how often we are going to perform this maintenance. Okay, so now CI/CD maintenance, when we talk about that, there is no fixed time that you have to do this at this point, because we run pipelines regularly. So it is possible that at some point there is some issue happening within the pipeline. For example, let's say I am running a pipeline, full stack pipeline is there, including the Docker stage. So during the building of the Docker image, we got an error that let's say Docker build failed, and in failed, and it's written there, it failed due to missing dependency. Okay, and here it is also mentioned that what dependency is missing. It's missing Python 3 pip. This is the dependency that is missing. So first basic information we got to know when the pipeline failed. Next thing that we have to do is we have to go to pipeline logs. Now this pipeline could be in Jenkins, it could be in GitLab CI/CD, or it could be in GitHub Actions. So we have to go to the logs of that pipeline, and there we have to check. So in pipeline also we might be able to see some more information, but eventually we understood that this dependency is missing from the Docker file basically. So what we can do, we can basically open our Docker file and add this specific stage. We can add run apt-get update and apt-get install python 3 pip, and this is going to install, or this is going to make sure that in our Docker image python 3 pip dependency is available, and then we can run the pipeline again. Okay, we need to run it, and then we need to monitor the pipeline if any other issue comes. Okay, so this is the kind of CI/CD maintenance that we have to do. When we talk about maintenance, this is what we generally do. Another task with respect to CI/CD that we generally do is that in companies it is preferred that the pipeline, the CI/CD pipeline, should be very fast. Okay, so generally, like me and my teammate, we had like multiple times we used to get asked to make changes in pipeline so that the time of running the pipeline is decreased. Okay, basically to make sure that pipeline runs for shorter time and completes very easily in very short time. Okay, this was some general thing that we used to do on regular basis with multiple pipelines, since we had like hundreds of pipeline. So yeah, at some point we received request that you have to check out the pipelines and find out if this pipeline could be made faster. Okay, so now you understand that this is what you can explain CI/CD maintenance as well as creation of CI/CD pipelines. Creation of pipelines will be done when new client onboards, where we have to guide them, or you have to create the pipeline from scratch. Whenever new project is onboarded, then also you have to do that. And sometimes what happens, we have to create new pipelines for specific task. Okay, for example, like some automation kind of task, or like let's say I want to create EC2 machines using Terraform, but I want to automate it properly, so I can create a CI/CD pipeline inside which I can mention everything. Okay, so this is how CI/CD maintenance and creation of pipelines can be done. So team, now let's talk about Kubernetes operations and pod management. Now let me explain you proper scenario how exactly this was done. So first of all, on daily basis, we used to receive an email notification. So in our Kubernetes cluster, we had 30 plus projects. Okay, so on daily basis, we used to receive email notification, and this email notification contained a kind of Excel sheet. Excel sheet has multiple columns, out of which first column was like this: the cluster, then the namespace, then pod, then issue. So this is the mail notification that we used to receive on daily basis, where whatever cluster, if we have, we had 4 or 5 clusters. So whichever cluster, let's say X cluster, inside this namespace was Y, pod name was Z, and issue was, let's say, crash loop back of error. Okay, so this was a very long sheet, and whatever cluster, inside whichever cluster, whichever namespace, if some pod is failing with some kind of issue, then we used to get notified over email. Like we used to receive one email notification on daily basis, inside which a list of pods will be there. So me and my teammates, we have to take out distribute pods among ourselves and decide who is going to fix what. So based on whatever issue is there, we have to fix it. For example, let's say we got to know inside cluster X in namespace Y, Z pod is having issue. So what we have to do, first of all, we have to log in inside the cluster, go inside namespace, and there we can first two general commands that we have to run, which usually told us what kind of issue is there. So the command that we used to run first is kubectl describe pod, then pod name, and then namespace. Okay, let's say Y. This would tell us about the pod, like when it was started, if it is able to start properly or not. Okay, and Docker image is getting pulled or not. Those information we used to get from this. Second command that we have to note, which used to give us complete information about what kind of issue is happening and what we could do in order to fix it. So for that, you can simply get the logs of the, we can run the kubectl logs, then pod name, namespace, like this. So this information is going to give us the pod is having what kind of issue. Okay, these are two general commands that we have to run in order to fix the issue. Sometimes the other command that we have to run, sometimes what happens, like you get to know from logs whatever issue is there. So in order to fix those issues, we get to know that we have to execute some kind of command, right? We have to execute some kind of command inside the pod. So for that, we have the kubectl exec command. Okay, using which we can go inside the pod and we can execute commands inside that. So in this way, we used to perform Kubernetes. See, this is the part of pod management only inside Kubernetes. Okay, this is one general thing that we used to do on regular basis. So yeah, this is something that you can easily explain in your interviews as well. Now let's move on to next task. So team, now let's talk about next one. So next up we have cloud cost optimization. Now let us assume that we are using AWS cloud platform, and now we just notice that as compared to last month, the bill that came is around 30% more. Okay, so first of all, what we have to do, we should be checking. Generally, one of the most common resource that we create in AWS is EC2 machines. So first thing that we should be checking is like if there are any unused machines that we are unaware of, or there are some EC2 machines that nobody is using but still it is running, right? So for that, one of the common command that we can run is like this: AWS EC2 instance filters name instance value stopped. Okay, so we could find what instances are in stopped state. So first of all, we can remove them. Also, there are another there is one kind of instances which is known as spot on instances or spot instances, I think. Okay, which is basically could be used for temporary works, and if you have to do some kind of experiment, you can use these kind of instances. Best part is that as compared to general instances, the cost of this is around 90% less. So if you want to do some kind of experiment, then this is good. But again, this should not be used for some permanent kind of or like task you have to do or like in production. This is good for experiments. Okay. Other than that, there are other commands also using which we can check out which resources are running, and like we could basically get a list of resources that are provisioned. Based on that, we can decide which resources are being used and which are not at all being used, and afterwards that we can run AWS like terminate command. For example, for removing EC2 machines, we have a command like AWS terminate, and we have to provide other information about the EC2 machine that we want to delete. So yeah, cloud cost optimization, this is one of the ways using which we can perform this cost optimization, which will be really useful. And again, I have taken example of EC2 because this is one of the most common resource that we create over AWS cloud platform and that we use a lot. Okay, but again, there could be many more ways for cloud cost optimization, which we can discuss later on as well. Now let's talk about next task. So this is going to be incident responses. So let us say that basically in this task, what happens, like let's say I'm selling a platform for a client to work on different DevOps tasks, and that platform is having all sorts of DevOps tools integrated. So let us say that client is facing any kind of issues with respect to DevOps tools. So what client can do, client can raise a ticket. Okay, there is a platform known as ServiceNow. So on that platform, client can log in with their credentials, and there they can raise ticket. Now tickets can be raised in, there are many ways to raise the ticket, but two general ways which we use. First is incident, second is support ticket. Now if there is some kind of critical issue, then client is going to raise the incident ticket, which needs to be resolved within 5 hours. If client is not having any kind of critical issues, but he requires some kind of guidance, some kind of support, then he or she can create support ticket which needs to be resolved within a day. So this was another task that we used to do whenever client, let's say client says that in their pipeline they are facing some kind of issue. So they can raise this incident ticket. It will be assigned to me or any other team member, whoever is available. We are going to get access from client to the pipeline. Then we are going to check the logs of the pipeline. Based on that, we can decide what we need to do in order to fix the issue. Okay. Again, it's written 5 hours, but sometimes it happens that issue is very critical and it requires more time to resolve. Okay, so this is incident response that again we have to do, and most of the tasks that we did within this section of work is basically troubleshooting and guidance for the client, whatever client needed guidance, because sometimes there were many clients who are creating new project and they needed guidance with like how they can set up everything. For example, like the branching strategy they want to do. Okay, so basically there was a little bit of consulting also where we have to guide client what would be the better ways for them to get started with their project. So like how many branches they should be having, how many environments will be good. So again, those things require so many factors. Okay, but yeah, this is one of the tasks that this is something that we did every single day, because obviously if there are so many clients you are working with, then some of them are definitely going to face issues like almost like one day or so. So yeah, this is something that we did on regular basis, and yeah, this is incident response. Now let us move to next one. So guys, next up we have POCs, which is something that that happens in every company. Now, what exactly is POC? So POC is short for proof of concept. What exactly does it mean? So basically what happens when you are working in a company, they are constantly going to add new features, integrate new tools and all those things. So obviously, let's say you have a certain pipeline, and you got to know that there is a new tool available in market. Let's talk about 𝗕𝗏𝗃. So you told your manager or you told your teammates that, okay, there is a tool, security tool 𝗕𝗏𝗃, which is quite useful. So we cannot directly integrate 𝗕𝗏𝗃 in our pipeline. Before that, what happens? Someone from the team will be given a task to explore 𝗕𝗏𝗃, perform hands-on, see if it is compatible with our project or it could be useful, see like what could be the pros or if there is any cons, that also you need to figure out. Then you need to prepare proper documentation. Before documentation, you need to make sure that you have set up an implementation for a demo. So all those things needs to be done. This could take like 15 days time or a month time to explore something new tool, and then you need to present that documentation to the to managers as well as all teammates. And this is going to be POC. So what it helps with, basically it helps with project team to understand that if this tool is useful or not, or if this could be integrated with our existing project or this existing pipeline or not. And yeah, me and my friend, we did a lot of POCs. Some examples I wanted to give you. So uh, actually I did a POC on backend installation of SonarQube plugins. So basically, when you want to install certain plugin that is not by default available inside SonarQube, what you have to do, you have to first download the jar file. Then you have to put that jar file inside a specific folder inside SonarQube directory, which is located on extensions plugins. So inside this directory, you have to, whatever jar file name is there, you have to put it there. Then you have to restart your SonarQube. And what it does, it's going to basically install that plugin directly inside SonarQube. So this was one simple POC that I did. Other than that, my friends also have done, there was one POC using, which was like GitLab plus Sonar. Now many of you might think that, okay, it's simply running SonarQube using GitLab. No, it's not like that. So basically the POC was about like this, the results of SonarQube analysis will be visible inside GitLab. Okay, this was one POC. And similar to that, we did so many different kind of POCs. And yeah, this helps to understand any kind of tool a lot. Plus it is quite useful when you have to integrate some new kind of tool or technology in your existing project. So this is something that we have to do on regular basis. So guys, next up we have another important task, which is from IAC point of view, infrastructure as code. Now basically what happens when you're working in a company, so for example, let's say I have given Jenkins to my client is using it, and I have given one slave also to client, which is having around, let's say, 4 GB of RAM and around 32 GB of storage. Okay, now later on client realized that they have multiple pipelines which they have to run, and that requires a lot of resources. So client suggested that, okay, I want to have basically client says that I want to bring my own virtual machine and add it as a slave. That virtual machine configuration will be like this: 32 GB RAM, and it is having 256 GB of storage. Okay, but the thing is, in companies generally we try to keep everything within company network. Okay, so client says, so we told to client that instead of buying this kind of virtual machine from outside, what you can do, you can pay us the amount and we can provision this kind of resource. Plus client says that, okay, I want the configuration of the resource machine will be this, like Ubuntu machine, plus that machine should be having certain tools pre-installed like Docker and other things. So what we did, we wrote our Terraform script. By default we'll be having at least one Terraform script to create machines, and the main point of that Terraform script will be like that it will be have the definition, it will the company network will be defined inside it, so that the resource that we create, whatever resource we create, it should be created within company network. So using this Terraform script, we create the EC2 machine or Ubuntu machine we created for a client with the same configuration that was defined. Then we used Ansible to configure the created virtual machine, like to install certain tools. Okay, and finally when the VM is created, we can hand over that VM details or VM access and everything to the client. So in this way it is being used. Obviously there are many other use cases also, but again, I'm trying to focus, I'm trying to explain you the things that were actually happening. Okay, so this was one of the scenario that we used to do from IC point of view. Next up, we have a task that is something that I never liked. So it's documentation. So when you are working in a corporate sector, specifically in DevOps or any other technical domain, what basically happens whenever you are doing something or something new is happening, we have to document it. Okay, so that later on, other than us, if any other team member want to learn that or want to refer it, they can refer the documentation. So generally, there are many other platforms for documenting. From Azure also we have something, but we used a tool platform which is known as Confluence. It's something that you can even deploy inside Kubernetes. It's a platform inside which you can perform documentation, and everything can be arranged in the proper way, which makes everything easily accessible. So in simple ways, just note that there is a task which is documenting everything, basically noting down all the steps that are being used to implement something. Okay, and it is just done specifically to like make sure that people who are going to come after us, they will have something to refer in order to understand the project as well as everything. Okay, and inside documentation we can have so many different kind of things. First, we can have project info, we can even have team info, we can have technical implementation steps, and there could be other things also. So there could be like other things, we can just create documentation of that inside Confluence. Okay, now let's move on to next task. See, team, all these things I'm explaining because we actually do these things in our companies. So team, next up we have cloud resource management. So let us assume a scenario where our teammates or some colleague says that he need to have some kind of virtual machine for some experiment. Okay, that means you need to have a temporary virtual machine. So what we can do in that case, we can create a EC2 machine using AWS CLI command. This kind of command we can run to create the EC2 machine. But wait, there are more. So when you are creating a virtual machine within a company, you have to make sure that you are following best practices plus security practices as well. For example, we need to make sure that the such access to the virtual machine should be restricted to Office IP only. Office IP only, and this can be done by configuring the security groups of the AWS platform in whichever security group we are creating the virtual machine. This is first thing that we need to make sure. Secondly, we need to assign or we need to attach the specific IAM rules that has minimal permissions that is required. Okay, for the user who requires the virtual machine. So whatever minimal permission that we need to give, only that much level of permission we can attach. So for that we can create a specific IAM rule, and then we can assign to that or attach that rule to the VM, and then we can share the details to a user. Also, one more thing that we have to do in since I said that we have to follow best practices and security practices. So let us say that client says, okay, I need to use it for 24 hours only. Okay, so what we can do, we can use Lambda and we can use CloudWatch to make sure that any unused instances after 24 hours, it gets terminated. Okay, so in this way we can create resource, give it to employee whoever is needing it for temporary usage, and then we can make sure we are following the security practices, best practices, and also we can make sure the machine is terminated after a specific period of time. Okay, so this is one of the tasks that we did in the section of cloud resource management. Now let's move to next one. So next task is something that we did not do every single day, but obviously in a month we did multiple times. So basically we can call this as warm-up guidance. So basically what happens whenever a new client onboards. So initially it is possible that they might not know about complete DevOps. So as a DevOps engineer, if I'm supporting that client, basically me and my teammates, we used to work as a shared resource. So in shared resource, what happens, you not only work on just one project, you work on multiple projects and provide support to multiple clients. So whenever new client used to come, we have to dedicatedly connect to them for a week, and in that week my task was to guide them. Guide them with what? So I had to guide them with creating CI/CD pipelines. What is the best way to create CI/CD pipelines? Like we should be going scripted or declarative, what we should be using, which source code management they should be using, how they can integrate that. Then what in security tools, what they should be using, like Trivy we have, then we have Sonar, we have for pen testing, we have tools. Okay, so I needed to guide them how we can integrate those as well. And then whatever deployment platform they are using, for example, like OpenShift, AKS, EKS, or self-hosted Kubernetes cluster. So my task was to guide them how to integrate that as well. Okay, so these kind of tasks used to take around like a week or so, and this was simply in simple words we can say that warm-up guidance, where I used to help clients to understand and basically show them some kind of demos, small demos only, so that they get very good idea about how you can work with these things. So this was one task that we did not do every single day, but yeah, whenever new client came, then we have to do this. So guys, next up we have repo management, or basically management of source code. Now, generally anyone would think that only DevOps, only developers are going to manage that everything. But from a DevOps engineer point of view, there are many things that we also have to handle within the source code. And let me explain you with some examples. For example, we have this, let's say we are working with a Java-based application. So in that we have pom.xml file. Now, generally this file is going to contain dependencies. But other than dependencies, also there are certain things that we as a DevOps engineer we have to handle it. What kind of things are there? For example, we want to publish our artifact to Nexus. So those Nexus URL and repo ID we have to add here in pom.xml, and again that needs to be done by us. Then when we are working with SonarQube, so if you want to generate like a Java code coverage report, so for that also we have to add Jacoco here. Again, these are the certain things that developer is not going to do, but as a DevOps engineer we have to do. Okay, not just that. There is similar to pom.xml file, we have files like package.json in Node.js, and we have CS files inside .NET based projects, right? So in Node.js based project, we have to manage this. We have to, whatever thing is required from a DevOps point of view, we have to modify this file. Okay. Similar to that, there will be one CS proj file, which is another dependency file, where we have to make sure that everything is added properly. And from DevOps point of view, if anything needs to be added, that we have to do. And similarly, in Python, we have a file which is known as requirements.txt. Now, the project, whatever it is using, whatever kind of dependencies or library it is going to use, that needs to be added here. So most of them will be already added by developers, but there are certain things that sometimes we have to add as a DevOps engineer. So yeah, when we talk about repo management, we do have to modify some things and we do have to manage it.